Okay, so the research here is, or the work done here is mainly done by Todd, but unfortunately he wasn't available to come. But he will be putting out a more detailed research white paper here in next couple months if you want to go into the details. But we'll get right into it since I got 10 minutes. So in terms of the distribution systems, as you know, in the data centers, power is ever increasing, the densities. UPS, we've got three main models that we see deployed. The double conversion, AC to DC to feed the batteries, and then it's converted back to AC. You lose quite a bit, about 30%, depending on where the load goes in terms of the overall utilization of the UPS. You've got the delta conversion, which is the majority of the power passes through, and it's just filtered to clean up the waves, but the small portion is diverted, so you've got a bit of inefficiency sitting there. And then you've got the flywheel, which doesn't have any conversions because there's no batteries, it's just a flywheel. So looking at these different UPS models, and Lawrence Berkeley did a research paper on this, I think it was last year that it came out, or he had 06, that shows you that. So on the x-axis you see the active kind of power load across the UPS, and the efficiency on the y-axis. So as you can see, they all pretty much share the same kind of efficiency as you get low into the total UPS. So you want to make sure that you're loading your UPS effectively and making sure that there's enough power load across there. As it gets up, that's where you'll see the differences. The various lines for the double conversion are the different brands. You'll see one line there for the Delta because there's one vendor. So part of the downside in terms of that is that you get into vendor lock. So turning to DC power, again, obviously since it's straight DC, you remove the need for any multi power conversion and the related inefficiencies that get there. DC, if you've been around telco land forever, it's proven maintenance in terms of server farms and reliability record is still there. Still don't see it widespread across all data centers, just this kind of, I'll say, innate fear of DC for some particular reason. You do get the downside on the DC power is that you lose some during the transmission due to the lower voltage, neg 48. And we're seeing in data centers really looking at some interesting things in terms of high voltage to negate that low voltage, the transmission loss there. And basically pulling out the high voltage anywhere from the 370 to 550, depending on the vendor's packages, all the way out to the distribution, to the racks. The third major component of inefficiencies in the data centers that we're seeing is in the power supplies for the equipment themselves, and this is really based upon the multi-voltage regulations within the power supplies or within the component systems. You'll see anything from 1 to 12, and so by reducing or by eliminating, if you're able to get to a standard kind of voltage across the entire system component, you'd really be able to take out the inefficiency from that particular step in the process. It's just a chart full of numbers that shows the relationship in terms of it's a chart full of numbers that shows the relationship between power and cooling, because the inefficiency is that's expressed in heat that's released. So as you look across here, and you'll see on the table on the right, 70 watts per square foot. If you extrapolate that out to 1,000 square feet of data center space, you're basically going to need a 20-ton crack unit to hit that. That's your N. If you want to do any redundancy, N plus 1, 2N, and you need to make sure that you've got plenty of that, because you're hitting those densities. And in today's world, we're seeing 5 times that. Now, you don't really see 350 watts per square foot across 1,000 square feet all the time, but you'll see pockets of that throughout the data center. So you got to address that issue. So what can you do? And this is really the most important thing, because I can show you all the nice, pretty charts and pictures and everything else. But you need to take a look at it from two different perspectives. From a design guidelines when you're looking at building out data centers, You need to look to the future, obviously. I think you've heard this, but the power densities, there's no kind of end in sight in terms of short to midterm kind of path, and so they're going to continue to climb. We don't see any, I haven't seen any forecasts that power densities are coming down anytime soon in the next 5 to 7 years, probably. Modular approaches to power distribution. This is within your data center. You got to be able to flexible to put the cooling where you need it and to extract the heat out from where it is. And as you're looking to build, plan along with that. If you're using the raised floor, you've got to ensure that you look underneath the tiles and make sure that there's no big pipes or cable, wads of cable going across there. In terms of the actual implementation, you want to look at, if you're familiar with the ASHRAE Technical Committee 9.9 specs that was released last year, great kind of hands-on guidance in terms of implementation. The specs you'll see implemented, you know, they are technical industry specs, so you'll see them implemented a little differently, site to site or organization to organization, but they're very critical in terms of implementing and watching your power and cooling needs within the data center. At the rack level, you got to do the correct placement relative to the crack units and the airflow patterns of the gear going in there. If it's front to back gear or top to back, you got to make sure that they're consistent throughout. Fix your cabling, please. Perf tile, put the perf tile in the cold aisles. Let the hot aisles be hot. That's the intent. High density racks. You know, good thing is to put them in the middle of the rows, obviously depending on the length of the rows and placement relative to the crack units, but pretty reasonable. 10 cabinets, 10 racks, etc. You can put them in the middle, and spend the extra $250 for the blanking panels. Again, it's kind of like the cabling, easy thing, but works very well. If you got little hot spots, always use the active extraction, or you can explore that. This is just sucking the hot air out. Again, that's the concern in terms of the inefficiencies and the power and the generation of the heat is to get the heat out. It's not necessarily the hard part isn't getting the cool air in. It's to get the heat out of the hot areas. And in terms of the rack cooling, take a look at some of the liquid cooling that's coming online. I think a lot of it's pretty interesting in terms of the different vendors getting things out there that you can actually use and in place that also doesn't take a complete retrofit of your data center. So that's the 7-minute talk.
If there are any questions, we can take them while John Kristoff comes up and we prepare for that. Questions? No questions. Excellent. Thanks very much.